Hey guys, I'm Bennett Alterman, and this is my Lab 5 Choose Your Own Adventure. So the objective of the lab that I've chosen is to observe the motion of a person falling and hitting the ground using physics principles that we've discussed so far in this course. So my system is made up of the person and the earth. The person is a mass of 97.52 kilograms, and the time step delta t that I've chosen is 0.033 seconds. The forces and interactions here at play are gravity and the contact force. The final results are that the final velocity right before he touches the ground is 4.23 meters per second. The force of contact exerted from the ground onto the person's feet is 5,643.87 newtons. The work done by the contact force, or the work done by the ground on the feet, is 0 joules, and the change in internal energy is 4,300.63 joules. So here in Tracker, we'll see the observed motion. So on the left we have a free body diagram demonstrating the physics involved while he is falling. So while falling, the only force at play here is the gravitational force, because his mass is large enough that we can neglect drag over this short distance. On the right we have an example where he's on the ground, showing that the gravitational force is still acting, but we do have an opposing contact force pointing upwards from the ground into the feet of the individual. So here we have tracker data showing the position of the person falling across time. So some important equations that we can use here. We know that the change in total energy is equal to the change in kinetic energy plus the change in potential energy, in this case due to gravity. Because the person and the earth are both in the system, the total change in energy is going to be 0. We can also calculate kinetic energy from 1/2 mv squared, gravitational potential energy from mgh, and we also know that work equals the change in total energy, which also equals the change in kinetic energy. Furthermore, the change in internal energy is equal to the work done by force of gravity plus the work done by the contact force. Lastly, we know that the change in total energy is also equal to the change in kinetic plus the change in internal energy. So here, running the computational model, we can see that as the individual falls, you have the force of gravity acting down, which is represented by the yellow arrow, and once they hit the ground, you'll see that the blue arrow indicates the force of contact that is increasing as they continue to crouch. So, calculating the final results, we can manipulate our delta E equals delta K plus delta UG equation to solve for final velocity by understanding that 1/2 mv final squared minus an initial velocity of 0 is equal to the negative mgh, or potential energy force, meaning that our velocity is going to be the square root of 2 times gravity and the distance fallen of the center of mass of our individual, and this yields 4.23 meters per second. Our contact force can also be calculated in a similar way. We know that the work done by gravity plus the work done by the contact force is equal to 0. So thereby rearranging, we know that the work done by gravity equals negative work done by the contact force. And work is just the contact force times the distance changed in the center of mass as this force is acting on the feet of the individual. So we end up with mg over the total distance moved by the center of mass over the distance moved by the center of mass while his feet were touching the ground and the force of contact was applied. And this force was found to be 5,643.87 newtons. We also know that no work was done by the ground on the feet, as the distance the feet moved while this force was applied is 0, because they remained on the ground in the same position. So the contact force by 0 distance gives you 0 joules of work done. We also know that the change in internal energy is equal to the work done by gravity plus the work done by contact force. And we now know that the work done by contact force is 0 joules. So therefore, the work done by gravity is equal to the change in internal energies. So we know that this is going to be mgh total, or 4,300.63 joules.